a lot of people view compost just as nutritional, a base nutritional to put out onto the soil. But if you can get your microbes into the compost and make it higher microbial population, then you don't have to view it as a nutrient, you can view it as a biological inoculant. And then you can have that biology in your soil, make the nutrients in your soil available. Like Gary was saying this morning, there's a lot of high phosphorus in a lot of soils, and that's because it's not available to the plant naturally. But if you get the right organisms in the soil, that can become available to the plant. You have it there, you just need to get the right organisms to make it available. So to make a good compost, you have to get the right carbon to nitrogen ratio, and then you have to get the right temperatures and the right curing time. So it's a little bit complicated to get it right, but instead of just making a big pile and putting it out as a nutritional, you can make a smaller amount and put it out as a biological. So as a biological, you only need 2 pounds per acre per application at strategic times during the year to re-inoculate your fields. So that way you don't need near as much volume and rather focus on a really high quality product. So that's where vermicomposting comes in, because the worms naturally have a really high microbiome in their gut. And so they'll basically take any feedstock you give them and make a really high microbial product. And that's where they're a tool that you can't replace. Like if you have a really good pasture, you're going to have lots of earthworms. They're doing that in your soil for you. But if you want to rebuild that good pasture, then you need to concentrate those worms in a vermicomposting system, inoculate your compost, and then put it out on your fields. So this is just a graph showing it's about 50 different food resources, recipes they use to make the compost, and it all came out with pretty much the same genetic makeup in terms of the DNA of the microbes in the soil. And that's just showing that the worms are the level playing field. You can put whatever you want into that bin, and the worms will verify that it's a good product coming out. But it also helps if you want really high fungal dominance. You can do a pre-composting process and maybe do a Johnson Sioux and then feed that into the worm bin, and you'll get even a better product. So you can vary the upstream to get higher levels of nematodes, protozoa, and fungi. But the bacterial content is all fairly consistent from the worm's gut. So then moving on, talking about some difference between compost extract and compost tea. Extract is essentially taking your solid product and putting it into a liquid form. So you're basically taking whatever was in that compost and liquefying it, and then applying that liquid to your field. It's just more cost effective to put 2 pounds per acre in 10 gallons than it is to spread 2 tons. And it's also a lot simpler to do. And if you look, the extract has the same DNA makeup. The microbes are the same as what was in the compost. And also extract, because you haven't activated, they're not growing, you have a much longer shelf life, which we'll talk about a little bit later. The tea, on the other hand, you've added in foods, you've added an air source, and you're bubbling it. It's kind of like a tillage event. You're stimulating certain organisms in that tea, depending on the food resources you're adding, and that same compost you used has now come down to about 5 or 6 strains of organisms that do really well in that high oxygen environment. So that's good if you're trying to do a really targeted foliar at a certain disease or pest. You can make your really strong brew and go out and spray it. But the problem with making tea is that it's not scalable. It's very hard to make 1,000 gallons of tea and then get it all applied without it going anaerobic. Versus extract, you can continually make extract, and then you can apply it and you have a much longer shelf life if something else comes up. So that's going on to the equipment we make. Our core of our business is the bioextractor. It's a flow-through compost extractor that allows you to basically continually liquefy compost. So essentially what we're doing is we have that top hopper, we have high pressure water jets, and we're augering up the material and introducing the water and just shaking the organisms, essentially washing them off the compost. They go through a screen into the basin and get pumped out, and you can put that into your sprayer or any piece of application equipment you want. And then the waste material would come out the front going into a bucket, and you can just recycle that right back into your compost pile. It's just a good brown material. So there should actually be no waste. It's just the biology is all off of it into the liquid, and it's just a brown, good brown material back into your compost system. This continual flow, which allows you're not constrained by size of your tank. So you can put in compost and set the concentration of the extract you want to make, and then you can go and fill up your sprayer, come back and fill up another one. It makes it on demand versus a compost tea brewer. You're putting a bag into a tank and bubbling it for a set amount of time, and then you can only use that amount you made. This you can make on demand, and coming out in December with varying flow options. So you can, if you're a smaller farmer, you can get a smaller unit to only make 300 gallons an hour versus the current one we have does 700 gallons an hour. It just allows you to scale your production to meet any size of farm you're farming on. Then, as I said, the extract is much more storable than tea because it's not active yet. It's just in a static form. All you've done is just liquefied that compost. So with a vortexing system, using a cone bottom tank, you can store that for up to about 3 weeks before you have to apply it. That number depends on temperature, concentration of the liquid you have, and then is it outside or inside, and are you getting those UV light to kill the organism. So if you have an inside confined space, air conditioned, you can get it up to 3 weeks. If you're doing it outside in a clear tank, I would recommend no more than like 5 or 6 days before the sun will have degraded that organism. But the key is you want to vortex it to maintain dissolved oxygen levels within the tank. And then different ways you can apply extract. You can use it to inoculate your bigger compost pile and make that a better product. You can use it to spray as a foliar, or you can use it in furrow at seeding. You can use it as a biodigester after harvest to digest the corn stalks or whatever was left over after you harvested to get those nutrients back in the ground and avoid having them be volatilized up into the atmosphere. So there's many different ways you can apply it when it becomes a liquid versus you're limited to how you can apply it when it's a solid. One example of a setup is Rick Clark. He's running a 7,000 acre certified organic row crop farm down in Indiana, and he is applying this in furrow on his beans and corn, and then he's also doing foliar passes onto his alfalfa and cover crops to just help keep that biology cycling. And he's seen some fairly good results on his cover cropping and alfalfa yields. So this is a video of him going into basically no-tilling in corn into a stand of rye. And then in that liquid tank, he has extract, and he's dribbling that in with the seed. So you're getting it in furrow. You're making the pass anyways. You might as well maximize that pass with some liquid biology. And that biology will stimulate that rhizophagy cycle that you saw earlier.